Gazing up at the night sky, we see countless stars. Each star is a sun, many with their own planetary systems. This vastness sparks our curiosity. Could there be life out there? If so, what might it look like? Imagination takes flight as we ponder these questions. We envision alien worlds, each with its own unique set of challenges and possibilities for life. The universe is a diverse place with stars of different sizes, temperatures, and ages. Planets orbiting these stars will experience a wide range of conditions. Some planets might be scorching hot, while others are locked in a deep freeze. Some may have atmospheres rich in oxygen, while others are shrouded in toxic gases. Despite these differences, life finds a way. On Earth, we have seen life adapt to the most extreme environments. From the depths of the ocean to the heights of the atmosphere, life thrives in unexpected places. This tells us that life is resilient and adaptable. It can evolve to survive in a wide range of conditions. Let's embark on a journey to explore 3 hypothetical alien planets. Each planet orbits a different type of star, leading to unique environments and life forms. We will discover how these alien creatures have adapted to their surroundings, showcasing the incredible diversity that life might exhibit across the cosmos. A hyper is a planet locked in a tight orbit around a red dwarf star. This close proximity means that one side of Hyper always faces the star, bathed in perpetual daylight. The other side faces the cold darkness of space, forever locked in night. Between these extremes lies a narrow band, a twilight zone where the sun perpetually hugs the horizon. This twilight zone is where life on Hyper has found a foothold. The oceans here are shallow and strangely dark, absorbing most of the faint red light from the star. These black oceans are home to forests of kelp, but these are no ordinary plants. Hyper's kelp has evolved a unique adaptation. It absorbs light in the infrared spectrum, invisible to human eyes. This infrared light provides the energy for Hyper's kelp forests to thrive. These forests, in turn, support a diverse ecosystem of creatures. Teardrop-shaped fish, their bodies streamlined for efficient movement through the dense kelp, graze on the plants. Camouflaged predators lurk in the shadows, their dark forms blending seamlessly with the black ocean floor. And on the seabed itself, blind creepers, their bodies adapted for a life without light, scuttle along, sensing vibrations in the water. In the dimly lit depths of Hyper's oceans, sight is less important than other senses. Sound becomes the primary means of communication and navigation for many of Hyper's inhabitants. The twilight zone is a symphony of clicks, whistles, and pulses, each sound carrying information through the water. The teardrop-shaped fish, for example, communicate with each other through a series of high-pitched clicks. These clicks bounce off objects in the water, creating an echolocation system that allows the fish to navigate the dense kelp forests and locate food. Predators, on the other hand, rely on low-frequency rumbles and growls. These sounds travel long distances through the water, allowing them to stalk their prey from afar. The blind creepers, meanwhile, produce a constant stream of clicks and whistles. These sounds create a 3-dimensional map of their surroundings, allowing them to navigate the ocean floor and avoid obstacles. They also use sound to communicate with each other, exchanging information about food sources and potential dangers. Nimbus is a gas giant, a planet with no solid surface. Its atmosphere, a swirling mix of hydrogen, helium, and methane, stretches for thousands of kilometers. Deep within this atmosphere, suspended in the clouds, exists an ecosystem unlike anything found on Earth. Here, life has taken to the skies, evolving to thrive in a world of perpetual twilight. Nimbus's clouds are not simply masses of water vapor. They are complex, dynamic systems with layers of different temperatures, pressures, and chemical compositions. Within these layers, tiny droplets of water provide a haven for life. These droplets, acting like miniature ponds, are home to a rich diversity of microscopic organisms. Among these cloud-dwelling organisms are the cloud plankton, the base of Nimbus's aerial food chain. These flat, four-legged creatures resemble spiders, their bodies adapted for clinging to water droplets. They use electrostatic threads, thinner than a human hair, to propel themselves through the air, drifting on the wind currents. The cloud plankton are not alone in their aerial world. Larger creatures, drawn by the abundance of food, have also evolved to navigate the skies of Nimbus. Among these are the sky whales, massive, buoyant creatures that drift through the clouds, filtering out the plankton. Their bodies, filled with lighter-than-air gases, allow them to stay aloft effortlessly. The sky whales are gentle giants, their lives dedicated to grazing on the abundant plankton. But even in this seemingly peaceful sky, danger lurks. Jet squids, sleek and agile predators, patrol the cloudy skies, their bodies streamlined for speed. They are masters of camouflage, their skin patterns shifting to blend in with the swirling clouds. The jet squids use their powerful tentacles tipped with sharp barbs to ensnare the sky whales. A well-aimed strike can cripple a sky whale, leaving it vulnerable to the jet squid's relentless attacks. The dance of predator and prey plays out across the canvas of Nimbus's sky, a constant reminder of the challenges and triumphs of life in this alien world. Monnier is a world of extremes. Orbiting a brown dwarf star, a dim and dying ember in the vastness of space, Monnier is locked in a perpetual deep freeze. Temperatures on this icy world rarely rise above -100 degrees Celsius, making liquid water a rarity. Yet, even in this frigid environment, life has found a way to take hold. Monnier's atmosphere, thin and tenuous, is composed primarily of nitrogen and methane. Green auroras, shimmering curtains of light, dance across the sky, fueled by the brown dwarf star's weak magnetic field. The surface of Monnier is a desolate landscape of ice and rock, sculpted by cryovolcanoes that spew plumes of ammonia and methane into the thin atmosphere. Life on Monnier is not based on water as it is on Earth. Instead, it relies on ammonia, a liquid at Monnier's frigid temperatures. Ammonia, though toxic to most Earth life, serves as the lifeblood of Monnier's unique ecosystem, facilitating the chemical reactions necessary for life to thrive. The cryovolcanoes that dot Monnier's surface are more than just geological formations. They are oases in the frozen wasteland, spewing forth heat and nutrients from deep within the planet. Around these cryovolcanoes, life congregates, drawn by the warmth and the promise of sustenance. One of the most striking inhabitants of Monnier's cryovolcanic regions is the magnetic flower. These towering structures, some reaching kilometers in height, resemble giant sunflowers, their petals unfurling towards the dim light of the brown dwarf star. But unlike their earthly counterparts, Monnier's flowers are not rooted in the ground. Instead, they levitate, suspended in the air by a complex interplay of magnetic fields generated by the cryovolcanoes and the planet's core. These flowers are not plants in the traditional sense. Instead, they are colonies of microorganisms, each individual adapted to a specific role within the larger structure. Some microorganisms living within the flower's petals are photosynthetic, converting the brown dwarf's feeble light into energy. Others, living within the flower's stem, are responsible for generating the magnetic fields that keep the flower aloft. Is a testament to the adaptability and resilience of life itself. Our journey through the hypothetical ecosystems of Nimbus and Monnier has given us a glimpse into the incredible diversity that life might exhibit across the universe. These alien worlds, though products of our imagination, are grounded in the principles of evolution and adaptation. They remind us that life is not limited to the familiar forms we see on Earth. The vastness of the universe, with its countless stars and planets, suggests that life, in some form, may be common. Though we have yet to find definitive proof of extraterrestrial life, the search continues. And as we explore the cosmos, both through telescopes and through our imaginations, we open ourselves up to the possibility of encountering life as we know it and life as we've never imagined it. The tapestry of life woven across the cosmos is likely filled with wonders and surprises that we can only begin to imagine. As we continue to explore, we may find that the most remarkable discovery of all is not the existence of extraterrestrial life, but the sheer diversity and ingenuity of life itself.